Hey guys, I wanted to go over a few examples regarding the parabolas that we talked about in the last video. So I'm going to go step by step, and if there's something you don't understand, again, don't hesitate to reach out to me so I can clarify, or maybe we can go over some together. So this example here has a parabola stated over here on this side as the general term. One thing I want to point out is that we have an x squared, which means this parabola is going to open up or down. Moreover, we're going to be using this the standard form of this parabola. So what we need to do is we're going to have to come up with this expression that's on the left hand side, move everything else over, and then we're going to have to factor out whatever's in front of y from the y and the k. Alright, so in order for us to get this first part, we're going to have to complete the square. So knowing that, I'm going to simplify this by multiplying by a negative 2, because that's going to get rid of this fraction that's in front of x squared. So once I do that, this is what I'm left with. I have x squared plus 2x minus 1. And I just distribute it to each term that is in the equation. So then the next step would be to factor this. Right now this is not a perfect square, so it has two factors. So what we need to do is we need to complete the square. So we already took care of the coefficient. This is 1, so then we take this value here in front of the x, divided by 2, we get 1, and then we square it. So once we square, we get 1. So this 1 is the one that we need for it to become a perfect square. So then we have negative 2y equals x squared plus 2x. So if we add the 1, then we have a perfect square here. But we just can't add 1, so we need to subtract 1 to maintain the equality. So we go minus 1, and then we still have this minus 1 in the original equation, so we go minus 1. So now all I have to do is simplify the right hand side. We did this whole add 1, subtract 1 to find the perfect square, so we have x plus 1 squared, and then we combine these two negatives right here, so we have minus 2. So we're almost at our destination. Remember, we have to solve for the x minus 8 squared, which is right here, so we have to solve for this. So then we get x plus 1 squared equals, and then I'm going to move this 2 over. It'll be minus 2 plus 2. And now the last part is we need to find the p. So whatever is in front of y, we're going to factor it out, which in this case is negative 2. So you're going to be left with x plus 1 squared equals, you're going to take out that negative 2. We're going to be left with y minus 1. So now that we have our standard form, right, now we can extract everything that we need in order for us to be able to find the focus and then ultimately graph it. All right, so I'm going to find the focus to answer this question, and I'm also going to graph it just to kind of, we can just do this with this one example. So let me go ahead and take this over to another screen here. All right, so let me just paste it here. Okay, so there is our standard form of this equation. So what do we know so far? Well, we know that the vertex is going to be h comma k, which in this case is going to be negative 1 comma 1. That's my vertex. And then in order for me to find the focus, right, I need to find that p-value, right? So it's going to be this constant that's in the front. So it's going to be 4p equal to -2. And then we solve for p, which we get -1/2. All right. So that means that the directrix and the focus are 1/2 units away from the vertex. All right. Another thing that we know here is that because p is negative and we're dealing with x squared, then it's going to open down, right? So if it's going to open down, then that means that the focus is going to be down here and the directrix is going to be up there. So let me go ahead and put an axis here. So if I go ahead and I graph the vertex, I have -1 and then 1. So the vertex is right here. Vertex is right there. I know it's going to open down. I'm going to go something like this. Go something like that. And then in order for me to find the focus, well, one thing I do need to point out here is that the focus will lie on the axis of symmetry of this parabola. So the axis of symmetry in this case is equal to x equals -1. So the focus is actually going to be on this x equal -1. So the focus for sure is going to be -1 because it has to lie on that line. We just need to find the y value. So remember, it's p units. So you're here. That's the vertex. So you must go down 1/2 unit, which is going to leave us at 1/2. And that is going to be our focus. And our directrix, you're going to go 1/2 unit up, right? Like that. And it's going to be y equals 3/2 because it's going to be 1.5. So we have found our directrix. We have found our focus. And then on top of that, we have already graphed it as well. Okay. So let me go over an example of one that's slanted and opening to the left or to the right. All right, for this next example, I want you to notice that we have a y squared, which means we have to put it into this form. Very similar, except now we have y squared, which indicates it's going to open either to the right or to the left. So one important thing to notice here is we do have a 1 in front of the y squared. This is going to make our life easier when we're completing the square. So right off the bat, what I'm going to do is I'm going to complete the square here, right? And then I know that I'm going to have to move everything over to the right hand side, which I will take care of as soon as I complete the square. So I'm going to take whatever's in front of the y, divided by 2, we get 3. 3 squared is 9. So 9 is the one I'm going to use to complete the square. So I have y squared plus 6y. So I need to add a 9 for it to be a perfect square. But then again, I don't want to just add a 9. I want to subtract the 9 to maintain that equality, because 9 minus 9 is 0. Then I have the 8x plus the 25 equal to 0. So we completed the square because this guy right here is going to be y plus 3 squared. And then I have this -9 and 25. So let me just go ahead and add that. So we get 16 equals 0. So now I just have to solve for the y plus 3 squared. So it's going to be -8x minus 16. And then just like we did in the previous example, I'm going to go ahead and just factor out whatever's in front of the x. So I have y plus 3 squared equals -8 x plus 2. Right? So here is my parabola in standard form. So we can begin extracting everything that we know. which is the first thing here, the little line right here, is the vertex. It's going to be h comma k. So in this case, we have h is -2, and then k is -3. And then the next thing is to find, well, let's go ahead and do the axis of symmetry, which is x equals h, and we get x equals -2. So that's going to be the line where the focus is going to be on. Actually, because we're dealing with the slanted one, it's not going to be x. Sorry, it's going to be y. So then we have y equals k. So we have y equals -3. So that's where the focus is going to be on, the y equals -3 line. So then the last thing we need to do is we need to find the p-value, which is the one that's going to give us how far away the focus and the directrix is on the vertex. So we have 4p equal to -8. We go ahead and we divide by 4, which we get -2. Because p is negative, what we know is that it's going to open to the left. It's going to open this way. So now, let me go ahead and put my axes here. Let me go ahead and graph it. So we have -2, 1, 2, and then -3, 1, 2, 3. So there is my vertex. And now my focus is going to be 2 units away from here. So one thing I do know is that it's going to open to the left. So let me go ahead and just go like that. Open this way. So that means my focus is going to be inside here. So I move 2 units. So 1, 2. There's my focus. Remember, it's going to be on my axis of symmetry, which is my focus. For sure, it's going to be -3, but I move 2 units over, so it's going to be -4. And then my directrix is going to be 2 units from the vertex. So if I'm already at -2, so I move 2 units, so it's going to be the y equals the x equals 0 line as my directrix. Alright. I hope these 2 examples helped you. One is on the x-axis, one is on the y-axis. If you need further clarification, please reach out to me.